Welcome back to Advanced RC Adventures. This is a channel where we investigate, explore, build and explain, upgrade and advance Nitro RCs to another level. A2RC here. Today we have the makings of a Novarossi R3 C-12. Right here, see we have our C-12 here. Nice big R for race and Rossi. This is a side exhaust engine. We have all the makings. This is, in a sense, kind of a hybrid between HPI and Novarossi. HPI made, or I guess requested Rossi to make 2 or 3 different versions of this engine. Up here on the head, the original head, we have race, number 3. Some shine cuts here. Got little cutouts or ports. This is a button head or an underhead engine turbo plug. And we have all the makings to putting this together. We're going to be utilizing some HPI branded parts made by Rossi. And we're also going to take a look at some of the original components. For example, the sleeve here, and we're going to make some comparisons to the HPI branded Rossi made components and the original Novarossi installed components. So let's move some things aside here and let's get started. So after you've cleaned everything, this is a used pre-owned block, and it did not have a great life from the previous owner. For example, you can see here where we have some jaw or vice grip or plier marks here. I had to clean up this area more for just aesthetics. It's perfectly fine. It didn't appear to crush the internal bore for the bearing or anything like that, but we had to clean up that surface. But we're going to make this brand new. We're eventually going to put it on the test stand and make it a ripper once again. So bearings are a perfect place to start. We've got 2 different style bearings today. This is a ceramic front bearing. This is a 7x9x6 bearing. And then on the crank here, already pre-installed, this is a original Novarossi 11x21x5. Now this is a steel chrome bearing. It's actually extremely difficult to find these Novarossi bearings in ceramic nowadays for these older engines. I am confident that they're out there somewhere, but at least having an original Novarossi steel chrome bearing is definitely great. And before we put the bearings in, let's talk about some light crank mods that you can do at home, and let's talk about why they could be important. So here on what I'm calling the leading edge of the crank, of the induction window here, so the crank spins this way, starts here, spins this way. This is the first edge of the induction window that opens up. And what we've done is we've taken carbide cutter here and opened up this window so that it can have a little bit easier flow for the air to come from the outside in through the carburetor and down. We did not mess with timing. There's actually like a 0.5 millimeter edge from the existing material here, so that the timing doesn't change. But what we've done is opened up that leading edge window to allow for a little bit smoother flow going into that induction window. We did not touch the back end or closing end of rotation. You can mess with the induction window all you want, but generally speaking, for just light modifications to clean things up, to have a little bit better flow, you want that beginning edge to be cleaned up You don't have to mess with timing. You can if you want to explore and do more. But if there's any other burrs or any other thing to kind of clean up, you can do that with the induction window at that time. And then the second thing is the bore itself. When the air and fuel mixture goes through the induction window and into the crankcase through this bore, they all have a certain diameter. This particular crank is very close to this rod journal and the balance lobe here, so you only have a little bit of material to mess with. So this bore started out at 6.83 millimeters, what I measured it at. And let's go ahead and measure it now. Let's take our calipers, measure our bore, and now we're at 7 millimeter, 7.15 millimeter. And so what that's done is it's opened it up about 4 to 4.5% larger on the diameter itself. But when you talk about the distance or the volume from that leading edge into that induction window, it actually provides about 8 to 8.5% increase in volume for that bore. So that is relatively small, but every little thing counts. So that leading edge grind, the volume increase here will help efficiency and a little bit more power. It is something that you don't have to do, and these are not crazy modifications. These are just small tweaks to the crank that you can do to provide a little bit better performance. So now let's go ahead and get out our propane. Let's warm up our block. We'll put in our front bearing first, and then we'll drop in the crank and put in that rear bearing, and then we'll be able to continue through the assembly process. Before we do that, we've got to take out that front shield. We leave one shield on just to keep out dirt and debris when the engine's running. But we're going to take off that back shield so that when it's installed into the engine, it can get proper lubrication. Both shields on the rear bearing have already been removed. So I like to use this style razor blade. And generally speaking, if you work on that outer edge of the shield, then that makes it come off pretty easily. So there we've popped off the shield. These are rubber shielded. It's a metal shield coated in a type of rubber or plastic. And there's some lubricant inside that we're just going to leave alone. So this side, now that it's been opened and the shield's been taken off, that's going to go towards the center of the engine. You can use, if your crankshaft allows, this style does, you can use this as a little tool. Make sure that opening is going towards the outside so that when we warm up the block, we install it here like this, and then the opening is towards the inside. So now that we're ready for that, let's go ahead and get our block warmed up. So now that we've got our gloves on here, you want to make sure that you stay protected when you use heat. You can use bearing pullers and installers if you want, but honestly, when you use a little bit of heat, whether it's heat gun or propane, which is what I prefer, it's quick and easy. You just keep moving your heat around, and you're not trying to heat up the whole block, even though of course the whole block will go hot. You're trying to warm up that front bearing area, and then right here in the center where that rear bearing is going to go. When you're using propane, you don't need special puller, and you do not have to worry about having independent or different style pullers or sizes for every single bearing type. With heat, it's universal, and it does take a little bit of practice, but it's something that everybody can do. Just have to be safe about when you're doing it. So we're going to come here. I like to try to keep the propane setting or regulation lower if possible. It allows me just to work that heat around. It doesn't have to be blasting. You do what you feel is best for your situation. Give it a try. Just moving that heat around, let it soak in to that front portion of the block. What that's doing is that the metal is expanding and will allow for this bearing to be seated, and then when it cools, that metal is going to contract and have a nice press fit. Face your bearing in towards the block and push it in there. Make sure it's seated flush all the way around. Take your crank out. Now you don't have to, but I generally let this cool just for a minute or two before I heat up that back portion of the block. Let's come back in here. We're going to warm up that center section of the block where that bearing sits. Crank in here, push block in there. Take a look down inside and make sure that your bearing is seated all the way. And you can also tell by if you look at your crank rod journal that it's in that groove down in there. So we'll let that cool, and then we'll keep you on the assembly. Okay, so now that we're cooled off, let's talk about the crank. This is the original Rossi crank. And notice we have our threaded shaft or stud here, and they actually silver soldered or brazed that in so it does not come out. You can heat it up and get it out, but you might warp or distort. But everything about it is exactly the same is what's now inside of the engine block. The timing, the bore, the balance lobe, the induction window, the bearing sizes, everything is the same. When you decide, or if you want to try, to bore out that hole, it's been my experience that you need to use an M42 drill bit. You could probably use a boring bar, depending on what kind of situation you have. But what you're wanting to do is you're just boring it out from that beginning opening here, and you're going from that opening to the induction window. You don't need to go any further because that's a big volume or a gap of space, air right there. You're just opening up this section from here to here. What I've also noticed is that if you don't use a collet, two things can happen. You can mar the surface of that bearing area, like if you use a Jacob's chuck or something, and it will make imperfections onto that bearing surface. The other thing is that you can accidentally warp or make that portion expand, because what we're doing is we're removing so little bit of material here. It is doing cutting, but it's doing a lot of scraping on that outer edge of the drill bit. And you're trying to force something bigger into a small hole, so it wants to bulge that area. So the collet helps to keep that nice and snug, and you can check your diameter as you go. The same thing within this area here. It can bulge this area out. And because you've got a big open induction window here anyway, you don't need to go into that space. So I generally just go from the end to the beginning of that induction window. So then I mentioned that threaded portion of the crankshaft. That's where that flywheel nut goes on, that pilot nut. A number of these, especially HPI branded C-12s, are like this, and some other engines. So the original ones came with like a black oxide stud. I like to use these stainless steel versions. It's the exact same size. This is an M5 and it should be by 25 millimeter long. And you want to make sure that you clean your threads. The only difference that I do maybe than some others is I like to use orange thread lock on this, and the reason why, this orange thread lock is right in between blue and red. You should still be able to use hand tools to get it out, but it's a little bit stronger than blue. So when you use blue Loctite on your flywheel nut or your pilot shaft, it shouldn't, or at least there's a increase like probability of this orange thread lock holding on to the threads of that threaded portion of the shaft, but the blue thread lock will come off. You can of course use a little bit of heat if you need to take this off, but it's supposed to be able to be removed with hand tools, similar to blue. It's just a little bit stronger. So again, from just experience, some of the easier way, especially when you're doing a full disassembly and reassembly of the engine, is you want to put something down inside that carb hole and you make the induction window open. I like to use a piece of wood. You can use a piece of plastic, just don't use metal. This is a piece of push block that I use to try to put in through the back and bring sleeves up. And it's a nice size. You just stick down inside of that carb hole down into the induction window, and when you rotate and turn this tight, that'll hold that crank in place. And it's a lot easier doing it like this. You get a lot more substantial something to hold on to when it's inside the block than trying to do it outside of the block. So let's shake this up, put a little bit of orange thread lock onto your threads. Let's start to thread that down inside. Get a little paper towel and just wipe up any excess. Thread lock, as you know, kind of goes a little bit, goes a long way, so you don't need a ton of it. And then we'll put down inside my wooden push block or my wooden stick, figure out a way to hold the thing. You just need to make sure that the stick stays inside, you're holding on to the block. And then you'll rotate this and you'll feel the crank kind of stop onto the wood. And then you just turn this by hand till it's nice and tight, and you take out your wood block. And that's a great easy way to install your threaded piece of shaft there on the crank. And hopefully that helps some other people out, because that can be kind of a tricky way, especially if you don't want to damage the crank. And hopefully that helps some people out. So let's keep moving forward. Let's put away that orange Loctite and keep moving on. So we're ready to put in the piston. And this is a brand new piston and sleeve, brand new rod. And wrist pin and clips. Let's take a look here. So this is specifically an HPI branded Rossi part. So here's the rod. It's a 1918. It's the exact same rod as the Rossi branded. It's just, of course, a different part number for HPI. So, but just to make sure, we measured the bushings, we measured the diameters, we measure the entire rod just to double check, and it's the exact same. This is the old one. Whether it's new or old, these pinholes for lubrication, they're in different spots. You want to make sure that they're open, especially if you're going to reuse the rod and the engine's been gummed up. Find a needle, poke down inside there in both places and make sure there's nothing inside as you clean it up. And then let's take a look at the Rossi piston. This is well worn. Notice here on the Rossi version of the piston, the skirt's cut out, and that skirt faces towards the front of the engine so that it, on the downstroke at bottom dead center, it misses the balance lobe of the crank. So let's take a look at the Rossi made but HPI version. Notice that we've got a complete skirt all the way around. And me too, I needed to make sure that this was going to work out. And the good thing is that it's modular. The piston itself can go either way. But remember, for the rods, if it has a groove and it has this oil hole, and make sure you look at the bushing, it's going to have a chamfer. This faces towards the front of the engine. The back side, especially on nice made rods, this generally is ground flat, and that's so that when it goes on to the back plate, it can rub smoothly onto that back plate. So that oil hole faces towards the front of the engine. So one way to make sure is you simply put your piston on and you rotate this down to bottom dead center, and you just make sure that it clears. And this one clears perfectly, and it's possibly why, you know, the designers or engineers from both Rossi and HPI decided not to have to do the extra cutout on the skirt, because it does clear it. Now there's some, you know, extra safety redundancy with that sleeve or that skirt cutout, but at least as we see it now on the bench, that skirt doesn't need to be cut out, and that is maybe why when they made the HPI version, it's slightly less machining steps, slightly less expensive to make that that piston without that cutout. So we're going to make sure this rod journal is top dead center. We're going to put some oil down inside. We're going to lube up our piston rod and sleeve. And so these parts did come unassembled, and I had to put the wrist pin in. It's a captured wrist pin. There's 2 clips on either side. But as a lot of you may know, these small clips can be fiddly and you have to be careful. I generally use a gallon size baggie and get them in there just in case. If they do bounce off or fly away, they're trapped in that gallon size bag. But because they're so fiddly, it's just a lot easier, especially for time, to assemble your piston subassembly here before you get on camera. But it definitely can be done on camera. It's just up to you. I choose to do some of these pre-assembly steps just to make it a little bit easier for filming. So we're going to drop, remember that oil hole goes to the front. We're going to drop this down inside, put that piston in and the connecting rod onto that journal. Rotate this down to bottom dead center, and then let's take a look at the sleeves. The sleeves are effectively the same. This is notice it definitely has some time on it, doesn't it? We've got, let's start with the exhaust. This is the Rossi specific sleeve. Nice big open window. No real dog ears, but it's nice and big. Remember, this is a side exhaust engine. Transfer port, just with a small amount of bevel. We have a nice big bevel on the boost port here, and the boost port itself is a good size, and then the same for that transfer port on the other side. So this is an HPI branded specific sleeve, but it is the exact same. Everything about it is the same height, same thickness, same everything. When you compare the boost port and the bevel and everything else about it, it's the exact same. But let's take a look. It's a little bit easier to see with this one. Transfer port, I have a tiniest little a fang or bevel here on the edge of the transfer port. The same nice big open exhaust port. Transfer port on this side with a small bevel. And then a nice big opening and bevel for the boost port. So this piston and sleeve, HPI specific part number is 1922. They call it a piston and chrome sleeve set for the 12R. So the HPI engines, branded Rossi engines, they still have a C-12 on the side, but they do not have the R for Rossi. It says HPI. So inside of the casting, they change that portion out so it says HPI on the side. But they're effectively the same. Some of them is, so like this Rossi specific, we have our sleeve indicator pin here, and it is different on most of the C-12 HPI versions, and it's in a different location. So you have to be careful when you're looking for sleeves in an attempt to use on a Rossi block. It needs to make sure that that indicator is in the right spot, because they do make other HPI/Rossi sleeves and piston sets for C-12s and for the 12R SC and the 12R RC, and the ports are slightly different, and that indicator pin location is in a different location. So that's something just to note and to consider, because not all of them are going to be the same. You got to do your homework and you got to make sure you know which one's going to work for which. So let's lube this sleeve up. Just put a little bit of oil on the inside and out. Put a little oil on the inside of that bore. And just like any other sleeve, this one has got a nice fit to it. Push that sleeve aside, make sure everything is nice and lined up the best way you can. Make sure it goes on the indicator pin. No sense in rushing this step. You want to make sure that everything goes in nice and easy. So now we have our sleeve installed. So we can set our block aside for a moment, and we can take a look at the black back plate. This is the Rossi specific back plate that came with the engine. The 12R SC, the bump style one, is the exact same. I actually have a brand new back plate that I could have used, but I wanted to try to use as many existing components I could, and this is a non-interference back plate. There's no groove up here, and we've got the original O-ring. But I have a new O-ring for that rear cover, that back plate here. We're going to open up. This is the 1929 HPI branded specific, but it's the exact same O-ring since they're all sister engines. So let's open it up and get that installed. So for O-rings, you need to, or you should lubricate them in some way so they install properly. And it's really just for installation purposes. And you can use what I use one of two things. Inside my bottle here, this is just an old after-run bottle if people were wondering. And this has synthetic 5W30 inside of it. And I use this for after-run oil if you want, but mainly for engine and carburetor assembly after everything is clean. And you can put some on and lubricate it and then put it on the back plate. But another thing that I like to use is Dow Corning Molykote 111. This stuff is really good. It's compatible with alcohols and silicone, butyl, and other types of O-rings. A little bit goes a long way. You just rub it on your O-ring Some people say that it soaks in. I'm not confident that it soaks into the O-ring or not, but it's a nice thick lubricant that is compatible with alcohol fuels, and silicone and other O-ring materials. So I'm just going to set that there to keep it clean. And let's get this old O-ring out. Use whatever you think will work best. I like to use a little pick. You just get underneath it the best way you can and just kind of roll it and work it off. If you don't care, you can maybe just cut the thing off. But as long as your O-rings are supple, and this is still relatively supple, I might save this as a spare. You never know. But take a look at the stretch and size difference. Let's see if I can do this. It's going to be hard to see with my black gloves. But notice the size differences because this one has stretched so much. So set that aside. We have our moly coat on here now. And let's work this O-ring onto the back plate, put it down inside of its groove. There we go. Rub that moly coat or oil around just to put a little bit of lubrication on to that back plate. And then we are ready to put that back plate on. So that brings us to our next topic, or at least portion of the assembly step, where we have our bolts. And these are brand new bolts. The backplate uses M2.5. I like to use these stainless steel M2.5 if I can. As I've mentioned in other videos, you just want to make sure that it's appropriate size. So these are M2.5, and what I've noticed is that as long as you're you want to be as close to 2.5 as possible. The stock ones were, if I remember correctly, 2.47, something like that. They're always going to be slightly under. And this is 2.42. If you measure, and it measures like 2.2 or 2.30, that's way too small. And what's going to happen is that there's not going to be enough thread engagement on the face of the thread when it goes down inside of its hole, and you can actually strip it out or it won't hold as well. So you just want to make sure that your replacement bolts and hardware are just as good in the correct size as the original. So I put a little bit of oil here on the surface, and I just do a little dab of oil on there. That helps for installation purposes, but also there's a chemical reaction that can happen between different steels and steel alloys and aluminum, and it's a corrosion, and then they can get locked in there. And when the next time you try to take your bolt out, especially if it's a black oxide bolt, they can actually snap off in there, and you definitely don't want that to happen. I'm going to take a little bit of this oil, put inside of this bore and on the chamfer where the O-ring slips by. There's no indicator for up on this back plate. Put this down inside of here, push that O-ring in. We have our little lubed M2.5 screw. We'll get this one started, and then I'll also let's measure one in length and let you know what that is. So we know it's M2.5. And this is an 8mm M2.5 bolt. And then since this is O-ring sealed and it doesn't have a paper or plastic kind of gasket, it's not imperative to do a formal torque pattern on these back plates, but of course you can. You want to do it out of practice, go ahead. The other thing that's important is that you do not have to cram and get these so super tight. Again, what you're doing is you're trying to make that O-ring seat inside. The O-ring does the sealing. The back plate holds the pressure in. And yes, of course you need them tight, but you don't have to crank and cram on, especially since they're an M2.5. But the stainless steel, in my opinion, for all the years, they do a great job, especially for back plates. You can use them for heads too if you want. Yes, there's pros and cons to all the different materials that you can use for hardware, but I like these because it's one less thing to rust, similar to aluminum. Of course, everything corrodes in certain conditions, but it also just kind of, I don't know, in my opinion, I like the look. We've got a silver on kind of silver look, and they work great. So the head bolts, these are going to be an M3, see how long they are, M3 by 14, and these are brand new. These are Allen. A lot of the Rossis use flathead style hardware, and if you can change it to hex, please do. And these are the same length and same size as stock. So let's move some of this to the side for a minute, and let's take a look at our head button, because that's what's going on next. This is a turbo style head button, 4-bolt head. Cleaned this up. This is a 0.3 aluminum shim, and that's what's relatively standard or stock, so to speak, for 20-25% nitro for these 12 engines. You can shim up, you can shim down, depending on your preferences, as well as the nitro concentration used for your fuel. But this 0.3 aluminum is a perfect starting point, and that's what we're using here for this build. I like to put a little bit of oil on the head button or on the head shim, and that oil just helps to kind of hold that head shim in place, because as you guys know, people have replaced shims and rebuilt engines a lot. Those head shims can fall off, but now with that little bit of oil, it stays stuck on there. We took a little bit of a look at the head, but let's take again. Notice, so this is the stock head that came with this 12R 3-port, and it says race on top. It says number 3 for 3 ports. That head button is going to fit right down inside of there, 4-bolt style. There is no indicator for rear on this head button, so it doesn't matter. All you got to do is pop it on and line up your head bolts. So we've got our head button on there. Let's go ahead and put a little oil on our bolts, drop it down inside the head. Same kind of practice as the backplate bolts. So this particular head is directional. So there's a gap in between here to allow air to flow this way, but it doesn't allow air to flow all the way through this way. So depending on maybe your setup, whether the engine is this way or that way, left or right, collinear with the chassis or perpendicular, will depend on if you feel it important to have that airflow. I generally keep them so that the airflow is onto the left side of the engine to start, and then if for some reason I need to change, then you can. And then there's no specific cutout for like exhaust, since this is a side exhaust engine. So it's relatively universal. So we'll drop that down and give it a wiggle, make sure all of our head bolts are down inside. Set it on your surface and put a little bit of pressure down on the head just so it stays flat. And once you feel the head bolt touch lightly, you don't want to tighten it yet. You want to move on to your next head bolt until it touches. And you do all 4 that way, and then you can go ahead and use your torque pattern to tighten up your head bolts. So there we go. It's coming together now, isn't it? Nice, pretty Rossi purple / HPI kind of dark purple head on this nice bump start 12R Rossi C-12. So we've got a brand new pinch bolt here. Put a little oil on that pinch bolt. Uses a standard 6mm nut on it. I generally like to, as long as the engine allows, I like to put the pinch bolts in from onto the right hand side. And that doesn't really mean you have to. You can put it on either side, but I generally install these engines on RS4s, and it's easier to have the pinch bolt on what would be considered the back side of the engine. Sometimes you can access it while installed onto the chassis, sometimes you can't. But it's just a preference thing, it does not matter. So we have our Novarossi all billet 3-needle carb. It has a 5.5mm Venturi, all brass hardware, slide carb, 3-needle. So we have our high speed, we have our low speed, which connects to our spray bar, and we have our third, what's considered a mid-speed, and that adjusts the mixing cone. And we have a brand new O-ring for the bottom seal of the carburetor, and this is the HPI part number. It's 1991 outer O-ring for carb, and you can use a Rossi specific, but it's the exact same seal, just with an HPI part number, since a lot of these parts are shared by their sister engines. So you take your O-ring, you can use some of your synthetic engine oil, or you can get your Molly coat back out. Since we have it, we're going to use a little Molly coat. You do not need a lot. A little bit goes a long way, like I mentioned. And you rub that into your O-ring, providing some protection for the O-ring and a nice seal. And we're going to put that on the base of the carb. And then once it's on, you just push it down. But if you need or want to, grab a Q-tip, clean Q-tip, and just wipe out that bore to get that out of there. This carb is going to be ran on this engine, but in a later episode we're going to do a full rebuild on this carb. This particular one, it does run just fine. It's been cleaned, but we are going to take out high-speed needle, low-speed needle with spray bar, new boot. All the seals inside are going to be replaced in a later episode of Advanced RC Adventures, and we're going to take a look and talk about carbs specifically, all their internals like the spray bar, and how the mixing cone works with it, how the high-speed needle helps to regulate overall volume and flow through the carb, etc. But for now, we're installing it onto our R12 Rossi. Just use your 6mm socket to cinch that down. You can put the carb either way. But what a beautiful engine, completely rebuilt, ready for the engine stand for a break-in for us to enjoy. And this great vintage engine gets to live a life another day. So feel free to like, share, and subscribe. Lots more to come in the future here with Advanced RC Adventures. If you like 10 scale, nitro, and especially touring cars, then this is the place to be. So thanks for taking the adventure with me.